So the first question on the quiz says to find the derivatives of each. So our first one, g of x, is from 0 to x of t squared plus 2t dt. Now, if you were a person that looked at that, you did the antiderivative and got what g of x was actually equal to, and then took the derivative, you could. But you're going way overboard to do that, because since g of x represents the antiderivative, when you take the derivative, it should just be the function inside. That is the first part of the fundamental theorem of calculus. So the derivative of this is just x squared plus 2x. That's it. Okay?
Wait, say that again?
I'm sorry?
What do you x's?
Because it's g of x.
So because our boundaries are x's, it is just the function inside. You take out the original t's and put x's. Now, think about the fact, okay, so let me prove it to you for a minute. Let's say that we evaluated that. We actually did the integral, okay? Would you guys agree that g of x is x cubed over 3 plus x squared from, oh, I'm sorry, t, those are t's. They're not x's yet. Boop. Those are t's. From 0 to x, which would give us x cubed over 3 plus x squared minus 0, right? That's what g of x is once evaluated. But look what happens when we do the derivative. Oh my goodness. This becomes 3 t squared divided by 3. And this becomes 2t, which is t squared plus 2t. Oh, I'm sorry, they're x's again. Oh my gosh, I keep switching back and forth. I'm so sorry. So as you can see, why would you go about doing the integral just to undo it and do the derivative? The derivative of an integral is the function inside. The derivative of an integral is the function inside. Okay? Does that make sense why that happened the way that it did? Either way, the answer to this question is x squared plus 2x. So if you recognize that the integral would be the antiderivative, so as soon as I take the derivative, I'm right back where I started. Okay? Now, the problem with number 2, you can still do it. You can totally still do what I just did. But instead, you can just plug in x squared this time and multiply by the derivative of that function, because it's kind of a chain rule, okay? So for this one, you just stick in x squared, and then you multiply by the derivative of x squared, or multiply by 2x, okay? So the first two on the quiz on Thursday are going to be, I'm going to ask you to find the derivative. One will have a boundary of x, and one will have a boundary of f of x, some function of x, okay? So it is your job to just recognize that and know that rule. The fundamental theorem of calculus says that the derivative of an integral is the function inside, okay?
This one is just, you just plug in the top. Both of them you just plug in the top.
Well, because of the fact that we know that the derivative of a constant is 0, so when we, even if that was a number like 1 or 2 or 7 or whatever, it would end up going away when we did the derivative, so that's why we don't need that.
And then you want to multiply by 2x?
If it's a function of x, you always multiply by the stuff. Remember, if it's stuff, you plug in the stuff and then take the derivative of the stuff. It's a chain rule type problem. You plug in the stuff and then you multiply by the derivative of the stuff.
And the derivative stuff is like the inside stuff.
Mm-hmm.
So if it's the 1 plus x squared.
No. The derivative of x squared is 2x. So that is your derivative. So that's the derivative of x squared. Okay? Okay, so the first two, I hope, are just easy type problems. Okay? So let's take a look at number 3. So if they just want us to evaluate an integral with boundaries, so that's a definite integral. Eventually we're going to talk about indefinite integrals, but a definite integral, remember, we're just going to take the antiderivative, go backwards, and plug in your boundaries. So our first one here is going to be 2x cubed over 3 minus 12x squared over 2. Let's just make that, let's just make that 6x squared plus 13x. And our boundaries are 1 and 3. So if we do the boundary, if we plug in 3, we get 18 minus 54 plus 9. So I'm going to plug in the 3. And I'm going to subtract when I plug in the 1. So that's 2/3 minus 6 plus 3. Okay. And then you are going to be able to use a calculator. So just plug that into your calculator.
Maybe 13. Yeah. Yeah, because up there it's a 13.
Oh, 13.
Okay.
13. So 13 times 3 is what, 39? Yeah. Oh, thank you. Okay.
I was looking at mine.
No, I'm sorry. And then we get an answer of negative 14/3. Okay. So 3 is just, your antiderivatives. Uh-huh. You're welcome. Now let's take a look at 4. Okay. Now on these, if you take the antiderivative correctly, if the problem's worth 4 points and you just mess up the plug-in, and you're only going to miss 1 out of the 4, so it's not going to be a huge, blow if you just plugged in wrong. But this one has a 0 in it, which is sometimes a little easier to plug in. Let's go ahead and do number 4. So that's going to be negative x to the 4th over 4 plus 3x cubed over 3. So let's just make that x cubed minus 2x. We're going to plug in our boundaries of upper bound 3 minus lower bound 0. If we plug in 3, we get negative 81/4 plus 27 minus 6. And 0 does indeed make everything 0, but always verify that because that's not always the case. So negative 81/4 plus 27 minus 6 is a final answer of 3/4. Okay, so that is number 4. Now, number 5 is pretty nice because it's a long problem, but the boundaries aren't totally horrible to plug in. So if we do this one, so we're going to do the antiderivative. So that's going to be x to the 6 over 6 minus 4x to the 4th over 4. It would just be x to the 4th. 4x squared divided by 2 is 2x squared, and then plus 4x. And then we've got these boundaries of 0 and negative 1. Now be careful when you have the 0, then the negative 1, because your signs can mess you up a little bit. If we plug in 0, we do get 0. I am going to put that front 0 there because then that will help me remind me that we have a negative to deal with. If we plug in negative, so you would divide by 4. Is that what you mean? The 4's cancel. Now you can write those numbers there and then reduce it down later. That works, Okay. So now if we plug in negative 1, we get a positive 1/6. We get a minus 1. We get a plus 2 and a minus 4. So our final answer would be the following. 17/6. So that is number 5.
I thought I did really bad on this actually.
Again, we have some yuck to deal with. When you undo a 1/3, the power goes up to 4/3. What I always kind of do in my head is I just add the denominator up to that numerator, and that will work every time because you're adding 3/3. So 1/3 plus 3/3, 4/3. But we have to divide by 4/3, which is the same as multiplying by 3/4. So that 4 times 3/4, the 4s do cancel out nicely. So we do have a 3 there. And you can show all that if that helps your brain to cancel things out and show every step along the way. Go for it. But it does become a fairly nice number. When we plug in 0, we're going to get 0. When we plug in -3, let's analyze that for a minute. Okay. So think about if you did the 4th power on a -3. It would become a positive 81. And then it would become 81 to the 1/3 power, which is just the cubed root of 81. Now let's analyze what that does. 3 cubed is 27. So that's really 27 times 3. We have 4 3s. That's where the 4/3 comes from. We have 4 3s. We only need 3 to evaluate. So this will pop out and just become a 3. So it will multiply by what's in front. So we get -9 cubed root of 3 is the best way to write your answer. Okay. Now, if you left it here, I'm going to go, you could have done better, but I'll give it to you. But you should technically go all the way down to that spot. Okay. So since 27 is a perfect cubed, so 8, 27, 64, 125, those are perfect cubes. That's the way that I did it. So I use the 4 first, -3 to the 4th is 81. Then I use the cubed root as the bottom. So remember, the top is a power, the bottom is a type of radical that you've got. Okay, so that is number 6. Everybody good so far? Yes. Yeah. Yeah, okay, let's go over it one more time. So our power went up by 1, it became a 4/3. I have to multiply by the reciprocal of that, 3/4. So the 4 that was there and the 3/4, the 4's cancel, only leaving me a 3. Okay, now I got to plug in the 0, it just got 0. If I plug in -3, I just showed it at first. And then I did it in 2 steps. I did the top power first. -3 to the 4th is where I got 81. And then I tried to cube root it. A cube root, I have to look for perfect cubes that it contains. 81 is divisible by 27, so I wrote it as 27 times 3. The 3 comes out, multiplies by what's there, it leaves a regular 3 back behind. Okay? No. Okay, so yes and no. I mean, like, because you can use a calculator here, that's okay. But when we get to the point, when we get to our final exam, they will not give you a decimal on there. It's going to be multiple choice. So now, technically, you could plug every one of those in until you get the one that matches your decimal. So it's okay. But just get in the habit many times that exact answer is what they're going to be looking for. Especially like if you go further to another calculus later on in your life. Okay. The plugging in is not my biggest concern. Okay, number 7. I am going to do a rewrite on this. I'm going to rewrite this as -4x to the -3 before I begin. So rewrites on these are sometimes possible or helpful. Okay. Okay, number 7. If we do that, we have to make the power go up by 1. If I add 1 to -3, I get -2. So it's really going to be x to the negative 2. Negative 4 would divide by negative 2, just leaving me negative 2x to the negative 2. But I'm going to write it like that now. Now, you don't have to, but it's helpful. Okay. If I plug in negative 1, yes? Oh, it should be a positive 2. Yes, it should be. It should be either 2x to the negative 2, or you can rewrite it like that. Both of those are perfectly equivalent. Thank you. It should be a positive. 2 negatives cancel, get to a positive. Okay, so now let's plug in negative 1 to either version, doesn't matter. Negative 1 squared is positive 1, so that's going to be a 2. Negative 4 squared is 16. 2 over 16 is 1/8. So that's going to be 16/8 minus 1/8 is 15/8 for an answer for number 7. Okay?
I like the question.
Yeah.
You're probably going to hate asking this.
Oh no,
Can you
go
do
for it.
Without rewriting it?
It's very difficult to do it without rewriting it.
Okay, because I was putting fractions over fractions. And it just was off.
Did you get anything close to what we
I
got?
didn't even finish it.
Okay.
You didn't
That
get
I think that's why, because you have to do a rewrite. Okay.
Oh, number 8, you just cancel it out. Of course.
Number 8 is awesome because the area from 4 to 4 is 0. So this is technically one that requires, it's called a U substitution. It's the opposite of a chain rule. We haven't learned that yet. So you can't do one like 8 just yet unless the boundaries are like that. So 8 is 0. Okay. Number 9 is a trig. To go backwards for a cosine, it just becomes a sine, and any constant in front just sticks on there. So this is going to be 2 sine of x from negative pi over 6 to negative pi over 4. Now, negative pi over 6 and negative pi over 4 are in the fourth quadrant. They're the same values as pi over 6 and pi over 4, but they're just negative. That's the only thing you have to remember there. If I plug in negative 30, negative pi over 6, it's just 2 times the sine of negative pi over 6 minus 2 times the sine of negative pi over 4. Okay. Pi over 6 is our 30. The sine is 1/2. So it's negative down there, so that's negative 1/2. The sine of any pi over 4 is always square root of 2 over 2. In that quadrant, though, it would be negative. So we can't do a whole lot with this. It would just be negative 1 plus square root of 2. And so that would be the answer for number 9. Yeah, you'd have to know the unit circle to do number 9. Okay, everybody get that? I'm sorry, I went a little fast there. So that's just unit circle stuff. Let's go to 10. The antiderivative of e to the x is e to the x. So this was probably, besides number 8, which was so wonderful, this should have been one of the easier problems on there. It's just e to the first minus e to the 0. The best way to write that is e minus 1 as your final answer. So, so that 10 is a nice one. So the antiderivative of e to the x is e to the x. So you just get to rewrite it and stick the upper bound in and the lower bound in. Anything to the 0 power is 1. That's why we got a 1 there. E to the first is just e. You don't have to write the 1. You could write the 1. I don't care. Okay. Let's take a look at our bonus number 8. This one you should have followed the same tactic as number 7. So I would write that as 4x to the negative 1.
Oh, shoot. No.
Actually, no, you don't even have to do that. But anyway, you can. Does anybody remember somebody has a derivative that the derivative is 1 over x? Natural log. So technically, this is 4 natural log of x. But their boundaries are funky, technically. The natural log only exists over in the positives. So there is no area over there. I don't know. Let's change the boundaries. Let's pretend like Mrs. Hunt noticed that. Let's do the boundaries. Let's go from 1 to 2. Because it does, you can't do it. Yeah. Okay. Anyway, that would just be 4 natural log of 2 minus 4 natural log of 1. And that's the exact value. You can get a decimal value in a calculator, but I like those exact values when all else fails. Okay. So remember that the antiderivative of 1 over x is always the natural log. Okay, because of the fact that it's just its own unique one. Think about if you tried to use the rule we have. If you add 1 to that power, what do you get? You get x to the 0, which makes it seem like it's a constant sum. It becomes 1. And so it doesn't work out that way either. So that's why you just have to recognize that if it's just an x to the negative 1 power, 1 over x, or 4 over x, or 7 over x, you have to go backwards and become a natural log. 10, we're going to skip now. That's why I made a bone. We just don't have the ability to do it just yet. But we can do 15. That's why I just totally skipped it. I'm like, oh crap, that's not there. But it was already copied. So anyway, let's do bonus 15. Yeah, I can't even show you bonus 10 yet. Eventually, but let's go to bonus 15. It is a piecewise function. If you look, I'm going to break it down for you, and I think you'll like it after that. Okay. Because it's actually a pretty easy problem. So what I'm going to do is I'm going to show you how to rewrite this problem, that it would actually become a very nice, pretty easy problem. Would you agree that from 0 up to 2, I have to use that, right? Because the function's graph only exists using this from 0 to 2. And then from 2 to 3, I got to use that. So that's the key to this problem. So we're going to rewrite this. From 0 to 2, I'm going to use x over 2 minus 1. And then from 2 to 3, I'm going to use x squared minus 6x plus 8. So that's just the key there. The key is the fact that our functions start over from 2 to 3 and then from 0 to 2. Did you get it? Okay. So let's go ahead and differentiate these. So x over 2, just you can think of it as 1/2 x if that helps your brain. But if we did x squared divided by 2, that's going to make that x squared over 4. It's going to multiply by the 2 that was already there. And that's going to be minus x. And then this is going to be x cubed over 3 minus 6x squared divided by 2 is 3x squared plus 8x from 2 to 3. Okay. So you're just going to plug in those boundaries. So if I plug in 2, I get 1 minus 2. If I plug in 0, I do get 0. So, it's a good idea to kind of just write that just in case you don't always have to get a 0. Okay. Now, for the second one, we just have a little more work to do, but it's not super hard. If you plug in 3, you get 9 minus 27 plus 24 Isn't 8 times 3, 24? And then we're going to plug in 2. We're going to minus 8 thirds minus 12 plus 16. Okay, let me combine these numbers right there. Okay, 1 minus 2 plus 9 minus 27 plus 24 is 5. Let me distribute in that negative. So 5 minus 8 thirds plus 12 minus 16 is negative 5 thirds. Okay. So the real quiz we'll do on Thursday. Please, at this time, take a picture of this, put it into Google Classroom for me. Keep this as a study guide.